So the apparent brightness of a star can be found using the formula B equals 6 minus 2.5 log A, where A is the actual brightness of that star. Determine the apparent brightness of a star with actual brightness of 3.16. Now this question is pretty much just substituting values in, but it is important to realize that when we are solving log equations and working with real life scenarios, we're probably going to be comparing two events that have occurred and looking at orders of magnitudes. Remember that logs deal with very, very large numbers or very, very small numbers. Okay, so they have given us B equals 6 minus 2.5 log of A, and they've told us that we need to find the apparent brightness given that the actual brightness, so A, is 3.16. So that means B is 6 minus 2.5 log of 3.16, and using our calculator, B is going to be 4.75. Okay, so therefore the actual brightness is 4.75. All right, loudness in decibels is related to the intensity of a sound by the equation L equals 10 log I over IO, where IO is equal to 10 to the negative 12 watts per square meter. That's a tiny number, okay? This value is the lowest intensity of sound that can be heard by human ears, definitely not my ears. An ordinary conversation has a loudness of 60 decibels. Calculate the intensity in watts per square meter. All right, so let's look at A. They've given us that the loudness is 10 log I over IO, and they've also given me that IO is 10 to the negative 12, and they have told me that the loudness, so L, is 60 decibels. That means that the only thing I don't know there is my I value. So I can say, therefore, 60 is equal to 10 log of I over 10 to the negative 12. And I can divide both sides by 10. So I have 6 is equal to log of I, and I can bring my negative 12 up there, okay? And that means that I can rearrange that. Remember, when I've got a log, I've got an invisible little base 10. So 10 to the 6 is equal to I times 10 to the 12. And I can then easily simplify that to I is 10 to the negative 6 watts per square meter. All right, now that says if the intensity is doubled, determine the change in loudness, not the actual new loudness, but the change in loudness. So if I want to double my intensity of 10 to the negative 6, well, I just times it by 2. So new intensity is going to be 2 times 10 to the negative 6. And they've now told me my new loudness is going to be, well, my formula is still the same, I over IO. IO doesn't change, that was my base. So L2 is 10 log 2 times 10 to the negative 6 over 10 to the negative 12. And that's going to be 10 log of, I can simplify that to 2 times 10 to the power of 6. And that I can write as, remember when we're multiplying there, we can split them out. So 10 log 2 plus log of 10 to the 6. And that's going to be 10 log 2 plus 10 log 10 to the 6, and that becomes 10 log 2 plus 60 log 10. Of course, log 10 is just 1, so 10 log 2 plus 60. Okay, and so my change in loudness will be L2 minus L1, and that's going to be 10 log of 2 plus 60 minus 60. So my change in loudness will just be 10 log 2.